Hello. This module introduces the concept of on-site preventive maintenance activities. The agenda of this module will cover the following topics: maintenance program, activities prior to the on-site visit, safety first considerations, activities description with physical verification of the facilities and equipment verification, maintenance protocol, activities after maintenance. The maintenance concept is related to correcting any failure in the moment that occurs or prevent such failures in advance. The maintenance activities can be divided in 3 categories. The preventive maintenance activities that are covered by this module. The corrective maintenance that is part of the Ceragon training programs included in the troubleshooting guide, and scheduled maintenance that is responsibility of any customer, including fuel supply and defect treatment. The preventive maintenance activities mentioned in this module give guidelines and summarize the recommended maintenance practices described in Ceragon and third-party user manuals. The maintenance program includes guidelines for different types of equipment present on a telecom site, but only the equipment applicable to the specific installation and site should be considered. The reliability and stability of the telecommunication equipment allows unattended stations. As an annual average, it is normally not necessary to have more than 2 routine visits per year. The maintenance routines are relatively simple to perform and most of the time will not affect the traffic. We can divide the preventive maintenance in 2 parts. Time-based, that is a periodical inspection, servicing, cleaning or replacing parts to prevent sudden failure. And predictive, that is an online monitoring of equipment activity performed in order to verify the correct performance and detect issues that can affect the reliability. The schedule showed in the screen is the Ceragon recommended preventive maintenance program with the time interval between visits. As we mentioned before, only equipment applicable for the specific location/installation type should be considered when following the recommended maintenance activities and procedures described in the Ceragon and third-party user manuals. Please observe what should be taken into consideration for maintenance every 3, 6, 12, or 60 months. The program showed in the screen is the predictive, online monitoring of equipment in order to verify the correct performance and detect issues that can affect the reliability. Please observe here what actions should be taken into consideration at what interval in time. For example, checking the status of the network element should be validated daily. Along with this, check proper operation, data communication network reachability, and that alarms are reported from the element. Please consider to troubleshoot alarms, like early signal degradation in correct time, as soon as indicators are present on the element. Every other week, you can browse the historical performance events on the elements, as a second example. Please observe the rest of the calendar to analyze what works best for your network or produce a different schedule, starting from the above-mentioned recommendations. Keep in mind that such a program is critical for any good performance network. Before doing an on-site preventive maintenance visit, it is very important to collect the following information: registry of reception levels, event and alarm records. This is important to decide if additional corrective actions are needed. This information can be obtained with the help of the network management system. Request and obtain the needed permits and access approval for the scheduled visit. Make a physical revision of the needed tools and material to be used during the maintenance activities. Obtain a copy of the previous maintenance visit or site acceptance test. Compare the actual received signal level, RSL, from management system against previously recorded values from maintenance records or site acceptance testing. This allows you to define if the received signal level is lower than expected value. Please make sure to double-check this aspect, as a small glitch in understanding the required received signal level might affect several people involved in maintaining a particular site. We need to mention that the preventive maintenance personnel must follow all the safety regulations and use all the security equipment required for performing any planned activities. Please take this as our strongest recommendation yet. The guidelines also specify not touching or moving the antennas, not holding any radio component in your hand while operational, and avoiding or minimizing exposure to the front of the antenna. Perform a visual inspection of the installation and verify that the equipment is not installed near or in contact with any power lines, due to risk of injury or death. Please follow these safety-first considerations with the utmost attention in order to avoid hurting you or damaging any equipment surrounding you. Arriving to the site and prior to accessing the facilities, you best inform the Network Operations Center NOC and get the approval for your visit. Perform a visual inspection of the conditions on site, verify the integrity of the facilities, that is access to the building or enclosure, the fences, the tower and mast, etc. Make sure to report if something is not according to what you were supposed to find there. There are 2 preventive maintenance visits per year, and the general routine is covering the following aspects. Physical verification of all the components. Visual verification of the weatherproof seals. Verification of the grounding system. Verification if received signal level is up to plus or minus 3 dB from the expected level at both ends of the link. Compare the actual RSL values against the previous registers, either from previous maintenance or site acceptance testing. If the link is working with adaptive transmit power control, check that ATPC is operating as expected, meaning the RSL equals the reference level which was set on the element. The terminal's bit error rate should be 10 to the power of minus 11 or higher. Verify no current alarms are present, and if alarms are present, start troubleshooting with the Ceragon troubleshooting guide from the course. Verify the logs of the terminal and clear after completing the maintenance routine. Verify that the correct time and date are set on the terminal. Fill up the maintenance record or protocol prior to leaving the visited site. Lastly, inform to the Network Operations Center about the conclusion of the performed works before leaving the facilities. Perform a physical verification and check the integrity of the facilities, including fences, building or shelter, gates and tower or mast, and report to the NOC if something is not as should be. Common sense usually does the job, but be alert for anything that can go wrong even in advance, by following with attention what is planned versus what you find on site. Maintenance of the grounding system should begin with a visual inspection of all ground points and site components, fencing, shelters interior and exterior, air-conditioned units, generators, fuel tanks, transmission lines, and the tower itself. To reduce the potential for current overflow between separate ground planes, these points should all be electrically common. During a visual inspection, look for corrosion that could cause breaks in the grounding system or for evidence that the system has failed, such as flash burns or bluing marks on metal faces and grounding connections. Continue with a resistance measurement of the system. To do that, measure the resistance between joints that should have to within 3 to 5 ohms of resistance. If corrosion or damage exists, this value will increase, and risk of damage is present on site. According measures will need to be taken next. As a reminder, it is necessary to wear the safety gear before climbing. Continue with a visual inspection of the platforms, cable support plates, the condition of the painted parts, and in case of a self-guide tower, check that all the wires don't show any damage. Check the integrity and operation of the obstruction light system. During the physical verification of the components, check the integrity of the radiation system, including antenna support, the antenna's radome, and the clamping system. Check that there is no trace of corrosion on any of those parts. In case that physical damage of any component is detected, take a note in order to plan a future corrective maintenance activities. For split mount or all outdoor systems, verify attachment of coaxial, optical or Ethernet cables, power cables, and cable ties conditions. In case of all indoor configuration, verify the waveguide hangers and additional fixation components. Perform a revision of the earthing system and verify that all the connections are tightened, no corrosion is present, and the weatherproof system is intact. Presented here are some more items to pay attention to, like the antenna reflector, the clamping used, the nuts and bolts tightening, the feeder connections, the cable ladder, etc. Check the integrity of the cable ladder, including tower attachments, paint conditions, and no trace of corrosion. Please use the following items, a small checklist of items, to verify during your inspection. Make a note for all situations that you believe can cause issues. Check that the antenna reflector is intact, the antenna clamping or support bolts and nuts are tight. Antenna stay clamping bolts and nuts are tight. Antenna mechanics are inspected for corrosion. Feed connections are inspected. Feeder run hangers are inspected. Feeder run earthing arrangement are inspected. Feeder wall feed-through plate is inspected. Cable ladder nuts and bolts are tight. Cable ladder is inspected for corrosion. During the physical verification of components, check that the radio equipment is properly installed, and all the fixation components are tightened as per Ceragon specifications. In case of remote mount of the radio frequency units, verify that all the screws in both ends of the waveguide are installed. Verify that all the units for both direct and remote mount are properly grounded. Verify that all the cable attachments are properly sealed and for both direct and remote mount. Check the integrity of coaxial cables, Ethernet cables, optical cables, and power cables are secured using black ties with UV protection and fixed at regular point intervals. Verify that all the cables are identified as per customer recommendations and weatherproof at the cable point of entry to shelter or building is correct. Perform the physical revision of the flexible waveguide and verify that all the screws in both ends of the waveguide are installed and properly tightened. Check the weatherproof of the waveguide and that the waveguide has no visible damage or crushed areas. In case of waveguide damage, make a note in the maintenance protocol, including the length of the waveguide, and suggest a corrective maintenance activity for correct. For all indoor installations, verify that waveguide connectors have no physical damage, that the elliptical waveguide is connected securely to antenna, that the waveguide connector is sealed at the antenna, and that the waveguide is secured using proper hangers to fixed points, at regular intervals on ladder. The activities also include verification that the waveguide has no damaged or crushed areas, and the grounding or lightning protection are properly sealed and labeled as per customer requirements. Verify that the waveguide is corrected pressurized following the test procedure for waveguide dehydrator. Part of the activities also includes verification that the waveguide has no damaged or crushed areas, the grounding/lightning protection are properly sealed and identified as per customer requirements. Verify that the waveguide is corrected pressurized following the test procedure for waveguide dehydrator. This procedure is detailed in the instructional manual for the dehydrator, supplied with the device itself. The maintenance of the pressurization system includes the physical revision of the components and the pressure test. It can be expected that all waveguide installations will exhibit some small amount of air leakage. For the waveguide pressurization and dehydrator test, check the time interval of the dehydrator operation in the respective manual. Run the dehydrator until all waveguides are fully pressurized and the air compressor automatically shuts down. Any air leakage will result with a gradual loss of pressure inside the waveguides. Observe the digital display on the front of the dehydrator. The dehydrator is programmed to automatically run the air compressor once a predetermined low air pressure is reached. The system is considered to work properly when there is more than 5 minutes between high air pressure when compressor shuts down and low air pressure when the compressor starts back up. If the compressor starts up again in less than 5 minutes, then the air leakage is considered unacceptable, and system will have failed the leakage test. The common leakage points in all indoor systems are the connector attachment, the pressure windows between connectors and branching, the air outlets, and the pressure connections. To find the leaking point, you can use soap diluted in water applied on the waveguide connectors and dehydrator connections so that the air leak will show soap bubbles. In case of a failed test, the field engineer must locate where leakage is taking place, then attend to the leakage and then retest the system as described above. This procedure must be repeated until leakage is controlled to within the guidelines for this test procedure. Correction of leakage in general is treated as corrective maintenance action because you need to disconnect the waveguide if leakage is in the pressure window. Continuing with the physical verification of the facilities and installed equipment under preventive maintenance, it is needed to check that the shelter or telecommunications room is properly connected to the main grounding bar as per site grounding specifications. Power and grounding cables are completely tied to the equipment, grounding and power supply/rectifier and routed properly inside the telecommunication room or shelter. In our images, the rack has been grounded to the main grounding bus utilizing the proper cable caliber and color code according to Ceragon specifications. The IP20 units have been grounded according to specifications, and the grounding terminals are crimped in correct way. Make a note to verify that all the cables are labeled as per customer standards and the power and grounding cables are completely tied to the equipment and power supply or rectifier. Measure as well the DC power voltage, which should be in a range between -40.5 to -60 volts of direct current for the equipment to function properly. Continue with the physical verification of the terminal's condition, including the fact that LED indicators should all be green, meaning no alarms are present on the element. Next, log into the unit with your computer using the login credentials. Provided and verify the following. First, the radio parameters, as transmission levels should be similar or identical to the ones stated in the site acceptance testing document. Next, check that reception level is according to the previous maintenance register or acceptance document. Check that MSE value is according to the working modulation, and in case of ATPC, verify the reference signal level. You should also verify the correct date and time of the terminal. Continue with the event and performance logs. It's worth mentioning that the IP50 and IP20 products contain a list of possible cause and solution for each displayed alarm into the system that can be used as troubleshooting starting point. In the Ceragon IP50 or IP20 units, the first screen after a successful login will show the general information of the terminal. After login, the unit summary menu is displayed and contains the terminal inventory, IDU temperature, Cera OS version, the date and time of said element. This is valid for software higher than version 10. The second screen in case of running Cera OS or onwards version is the radio summary page that contains the general information of the radio link from local and remote ends. The information to display can be tailored according to the needs of the customer and can contain the following items. System configuration. Received signal level. Transmission level, maximum and actual values. Mean squared error value. Modulation and radio capacity. For a complete verification of radio parameters, all the Cera OS versions contains a specific page per radio unit known as Radio Parameters page. In the Radio Parameters page is possible to check all the radio information and configure the operational parameters of each radio channel as radio type, serial and part number of the radio unit, actual received signal level RSL, transmission level, operational frequencies, link ID, RSL threshold value. The displayed levels should be similar to the stated in the acceptance testing document and/or according to the previous maintenance register, MSE, according to the working modulation. In case of ATPC enabled, verify the reference level or the RSL. Verify the actual bit error rate that should be better than 10 to the power of -11. The IP50 and IP20 products web menu contains a submenu page specifically designed for checking the actual alarms, with a description and severity of the event. As you can observe, this includes a list of possible cause and solution for each displayed alarm for starting the troubleshooting in case of issues. IP50 and IP20 products have the option to store an event log. The IP50 or IP20 event log has a capacity to register up to 5,000 events, including alarms that were registered into the terminal, containing a unique sequence number, time and date, severity classification and origin of the registered event. This should be consulted under the Faults menu, Event Log, in any IP50 or IP20 product. The event log can be cleared in order to start a new register sequence after perform the preventive maintenance. Please make sure you only perform this under request or with approval from the Network Operating Center, NOC, as these events might be needed later on. We cannot stress enough how important it is to have the correct time on your network elements. That is why we strongly recommend that you make sure the time is correct on the elements at each preventive maintenance window. Check the terminal time and correct if there is a mismatch in the time and date. Verify, as well, if the network time protocol is being used and functional in order to keep the time and date updated in an automatic way. Network management software has the option to also modify this registry on the equipment, so before you do any changes here, please consult with the Network Operations Center to have the updated or correct settings. One last thing to keep in mind here is to set the time format correctly. That means setting the UTC date and time correctly and also making sure that the correct GMT offset is reflected accurately for your time region. Discrepancies in these settings here might cause incorrect date and time registries in the event logs and NMS alarm pooling. The visual inspection of the rectifier and battery bank includes checking the physical conditions of the cable connections in the rectifier and battery bank. Verify that the rectifier has no alarms, measuring the input and output voltages from rectifier and verifying the battery cell voltage. All the measurements should be registered in the maintenance protocol document and kept for later use or reference. The maintenance protocol is the document that must be filled during the on-site visit, contains all the information and needed points that should be verified and recorded, as place, customer, physical and mechanical conditions of the site and installation, status of the terminal and additional observations. Part of the information is showed in the next slide. The following information is an extract of the contained information in the maintenance protocol. This document should reflect some important information, like the documentation to be taken with you on a site maintenance window trip, including site acceptance testing document, tower and building or enclosure planning, link calculation or budget, IP plan, transmission plan for the MUX. The link parameters with description of the link, signal levels, IP addresses, mask, router pass, in-band management option and network management system connectivity plan. Physical installation details about the antenna, pole mount, clearances, verticality and perpendicularity measurements, pole security, feeder system description, feeder polarization and antenna struts or sway braces. Grounding details for the site with checklist of the tower grounding or earthing plan, shelter and enclosure grounding, rack grounding, cable coloring and labeling and elements and cable grounding. This would conclude the guidelines we have for the maintenance window. At the end of all the maintenance activities, verify that all the points were checked, all values have been registered, and that no alarms are still present in the equipment. Inform the Network Operations Center about the performed activities, close the site, and leave the facilities. This module has covered the following topics: Maintenance Program, activities prior to the on-site visit, Safety First Considerations, activities description with physical verification of the facilities and equipment verification, maintenance protocol and activities after maintenance. Thank you for your attention.